All right, y'all. The time is now 9:03, so we can go ahead and get started. As a reminder, this educational webinar for June is focused on how Evolv AI measures impact through an optimization program. So we're going to be talking about things like variant performance, active combinations, and expected performance, as well as realized performance. So we'll cover what all of that means and why it matters. And your host today is Will Kaufman, our principal consultant for North Americas. I'll let you take it away, Will.
Thank you. Hey, everybody. Welcome to our third webinar. We're excited to be presenting today. So we'll get started. We have a whole bunch to cover. So in our last webinar, we looked at some of the common challenges in traditional A/B testing, like waiting to evaluate statistical significance, acting on false positives, and the complexity of analyzing impact that comes with testing across a customer experience. We then shared how Evolv and continuous optimization addresses these issues by making smaller decisions more often, auto-correcting for misreads, driving traffic to best ideas over time, and exploiting signals we might miss otherwise. It's a different yet powerful way of testing, and accordingly, we offer a new and mix of familiar ways of measuring the health and impact of your optimization so that you can understand the results and tell a compelling story to your stakeholders. So today we're going to take a look at 3 of those methods. First, like with traditional testing, you can measure the performance of your individual ideas compared to control, which allows you to answer your biggest questions about how to improve your customer experience. Next, evaluating the performance of active combinations or experiences is a reflection of what the system has learned and is learning about individual ideas, as well as a level of certainty in their performance. It's particularly useful in understanding the direction that your optimization is heading and how it responds when new ideas are introduced over time. Lastly, realized performance. This reflects the impact of all of your testing over time compared to having not run any tests at all. This is an important metric in calculating the return on investment from your testing. So now let's take a closer look at each of these to better understand what they tell us, how they're measured, and what to consider before taking action. So first up, variant performance. When using continuous optimization, the performance of individual ideas are first measured in isolation against control, similar to any other A/B testing tool. Considering these tests here to be run on this page, from there, the performance of each variant is calculated further based on their performance in different experiences or combinations, and the variants appear in those, and that is how the system gathers additional information about their performance. Based on all this collection of data, the performance range is shown in the reporting is a prediction of each variant's individual performance in isolation. So next, we'll take a closer look at the reporting of each of the individual tests or variants. Expected performance is calculated by using Bayesian statistics, which factors in prior performance. Using Bayesian statistics is actually one of the differences between Evolv AI and many other traditional testing platforms. Traditional testing platforms utilize frequency statistics most of the time, which do not factor in prior performance. The expected performance range is a credible interval for each variant at 95% confidence. Early in an optimization, it's normal for the credible interval to be pretty wide, but over time, as more data is collected, it'll tighten up. The red or green dot to the left of the variant name reflects the positive or negative mean of the credible interval for each individual variant. The probability to be seen tells us the degree of exposure an individual variant has, and is actually also kind of a reflection of how well that variant is doing. And that happens because the number of combinations that is included in is what drives the probability to be seen. And high-performing variants generally appear in more combinations as the AI tries to expose them to more and more visitors. So a higher probability to be seen is a sign that the system is recognizing a variance impact and is therefore validating it further and further against a greater portion of the audience. The session count reflects the traffic a variant has received from the first time it appeared in combination. Lastly, dormant variants are those which have been completely excluded by new generations of combinations. Test variants which have shown a significant drag on performance can end up being excluded from new experiences. Dormant variants will appear as the AI works toward creating higher performing combinations of ideas, which often end up including the variants which perform better and less so those that do not. That said, dormant variants can be revived as the system wishes to revalidate their performance, particularly in the presence of any new ideas that have been added throughout the optimization. So next, we'll take a look at some examples of variant reports and what they can tell us about our original hypotheses and our ideas. When the credible interval of a variant is fully above control, its expected performance is considered statistically significant. While this could be considered a winner to adopt in your control experience, the AI will continue to validate and exploit its impact as it's included in more and more combinations over time. This is a great example of a variant which would likely be allocated into more and more combinations. But because the AI continues to include it in more and more combinations, one of the features here is that it helps minimize the risk of adopting any false positives because it continues to validate. Variants with expected performance well below control are likely to become dormant as they become excluded from new combinations. As we mentioned before, though, it is possible for low-performing variants to remain in combinations longer than expected. This is in part the AI continuing to validate performance as well before ultimately potentially setting it to dormant. Lastly, at times, the performance of variants can be too similar to control. In this case, usually it means that it's a good time to add more ideas to your test. And this could be happening because when things are too similar to control, the system is having trouble finding a noticeable enough change between people having a non-control experience and a control experience. So it's important that the ideas that you're testing with your hypotheses are distinct and hopefully improvements to control in order for the system to notice that difference and start to collect and understand it. Any questions at this point before we move on? Next, we'll discuss measuring and understanding the performance of active combinations. As we highlighted in the beginning, with traditional A/B testing, when running multiple A/B tests concurrently across a customer experience, it can be difficult to analyze and measure the overall impact of your ideas. But with continuous optimization, the performance of individual ideas is calculated based on the performance of those appearing in each of the experiences or combinations they appear in. The performance of your current active set of combinations at any given time reflects what the AI has learned about individual variants and its level of confidence in their performance. Accordingly, the active combination's expected performance quickly lets us assess the health of active ideas, those variants which aren't dormant, and tells us the story of our optimization as well as its current trajectory. So let's take a look at that report. First, by default, this report shows the time range that includes the current phase that you're in for the project. That's either typically the initialization phase or the optimization phase. The optimization phase is what happens after the initialization phase, following all variants being introduced individually in isolation to control. So this time range can be customized to zoom in on different segments of the optimization timeline. The 0% line represents the control design, which active combinations are measured against. The range area is calculated from the performance of all active non-control combinations measured at 95% confidence. It tells us the lift and the range of expected lift The blue line is the median of this range. So you may notice some distinct features in this example graph. So we'll take a look at those next. A wide range of expected lift means that there's less certainty in the expected range of performance at this time. So you'll often see this at the beginning of a project phase when there's little data about the active combinations. So the range will be much wider. The range tightens after more data is collected and the certainty increases. Even after the range gets smaller, though, it can widen again as new combinations are generated and introduced into the system. While new combinations are generated, existing ones are deactivated. So new combinations being introduced could be a single new variant or a new set of variants together. But because they are new to the mix of combinations, this is when that bit of uncertainty can be re-added to the system for a bit, which is visualized by the wider intervals. But again, as more data is collected, the expected range will narrow again. Any questions at this point before we move on? All right. Next up, we have one of my personal favorites, realized performance. Realized performance reflects the impact of all of your testing over time compared to not having run any tests at all. When optimizing a conversion rate like add to carts or checkouts, the realized performance is the relative change in number of conversions as a result of running your tests. Additionally, when a conversion has an average value that can be associated with it, like completed orders, you can multiply that value by the number of conversions gained or lost to calculate an estimated value impact. Before we take a closer look at these graphs, I want to quickly go through how realized performance is calculated so that we can really dig into where that distinct value comes from. So we're going to go through an example. Let's say your website receives 100,000 sessions in a month, and your project is configured to evenly allocate your traffic across 10 combinations at any given time. This would result in 90% of your traffic receiving a non-control test combination and 10% of your traffic receiving your control. Each of these groups will have a corresponding conversion rate. In this example, the control group sees 100 sessions convert out of 10,000, resulting in a 1% conversion rate. So if you weren't running the optimization at all, and all of your traffic was to go to that 1% conversion rate, you would get 1,000 conversions. But you are optimizing. And in this case, let's say you're seeing a 5% lift in conversions across your traffic. This means of the 90,000 sessions receiving a non-control combination, we'll see 945 converting sessions or a 1.05% conversion rate. So what does this mean in terms of extra conversions generated by your test IDs? 945 conversions from the control group minus 900 conversions if the non-control group was converting at the original control conversion rate gives us 45 extra conversions generated from our test ideas that has seen non-control combinations. So from these numbers, we can now derive the realized performance. Realized performance is the difference in conversions between your non-control sessions converting at the control rate and your non-control sessions converting at the control rate, divided by the number of conversions you would have if all sessions received the control conversion rate. You can find these numbers directly in the manager towards the bottom in the sessions and converted sessions report, bottom of the overview page. So based on our example, your realized performance would be 45 extra conversions divided by 1,000 conversions if all sessions receive control, and that gives us a realized performance of 4.5%. Any questions about that calculation? I think I might have said control twice at one point here in the previous slide. I want to jump back real quick. The realized performance is the difference between your non-control sessions converting at your non-control rate and your non-control sessions converting at your control rate, divided by the number of sessions, the number of conversions you would have if all sessions received the control conversion rate. So when we do that math, this is where we net out. Any questions so far? All right. So to start, the realized performance and estimated impact graphs include the full lifespan of a project. This includes the initialization phase when the first variants are launched and tested in isolation, as well as the following optimization phase, which allows for multivariate combinations. The initialization phase at the beginning of the project is typically volatile because it's early on and performance is still working itself out. This is when each variant is being tested in isolation and all ideas are getting the same amount of traffic. So once the project transitions into the optimization phase, better variants will eventually be included in more non-control combinations to get more exposure. And this should help with increasing your number of extra conversions and stabilizing realized performance growth. For conversion-based projects, while realized performance measures the relative impact on conversions, the estimated value multiplies the number of conversions gained or lost by a specified average conversion value, or AOV. This value can be set in the configuration summary towards the end of the project overview page. If you do not see that in your project overview page in the manager, reach out to customer success and let us know, and we can help with getting it added. Consequently, when comparing the two graphs, you'll notice that they rise and fall at the same points. The value is often more exaggerated, though, in the estimated value impact because it's multiplying, whereas the realized performance is doing division. Any questions about realized performance or estimated value impact before we finish?
Is the realized performance is closer to the actual performance, or what?
So they're both a representation of that. The realized performance is, sort of it's a percent measurement of how much you've gained or lost based on running your optimization, whereas the estimated value impact is multiplying the actual additional or less number of conversions you achieved by an average order value. So they're very closely related, but they're represented a little bit differently in that realized performance is taking into account the fact that there's still traffic going to control, and it's measuring where you would have been if all traffic went to control. And the estimated value impact is just multiplying out, what you gained by doing your testing against your average order value, if your conversion event has an average order value or a value of any type associated with it.
Cool. Thank you, Will.
Sure. Does that all make sense?
Yeah, no, that makes sense.
Great. Yeah, so they're similar. Different representations of something. They're closely related, though.
Cool, thanks.
Sure. Anyone else? So to wrap up, we know you're not the only people that are curious about how your optimization is doing and that your stakeholders will have questions. So the performance reports we just covered can help you answer questions like what hypotheses need further testing, which can we draw conclusions on, are we seeing improvement across the optimization over time, or is the current set of ideas hovering around control? And lastly, has the bottom line been impacted to date? That's our relative performance, or realized, sorry. So yeah, I hope this webinar has helped folks get a clearer understanding of the statistics available within the Evolv AI Manager for measuring and understanding optimization projects when using our platform. I'm happy to answer any additional questions or circle back to any of the slides if anyone would like to do so. We have about 7 minutes, I think, to chat. You can hang out here.
Hey, Will. I think maybe it's something to draw a comparison between. This may go to the earlier question. While the realized performance is that gain or loss from running the optimization in the first place, the performance of active combinations is the expected performance of your currently active ideas, which is different than that gain or loss of conversions, and rather, when you look at the whole of the ideas that are currently active, the expected range of performance there is that conversion rate at that time. So, or is expected range at that particular time.
Yes.
And it's more a prediction of performance of those ideas.
Yes.
So in one regard, you can say the performance of my ideas is within this range. If we were to implement them, we could expect a range in that credible interval. But that's different than that gain or loss of conversions just from running the test.
Absolutely. Thank you, Jonathan.
Cool. Thank you.
So of course, we'll be sharing this presentation as well so that folks can absorb it and share it internally if they want, and of course, circle back with any questions.
I will also send out the recording. Of course, there are always folks that register and are not able to make it. So we will send out the recording and the deck. And of course, feel free to share those around internally. And if you have any questions that come up as a result of doing so, don't hesitate to reach out. Awesome. Well, thanks, Will. Thanks, everyone. I think we can probably wrap it up. Thanks so much for joining.
Thanks, everybody.
Thank you, everyone.
Thank you.
Bye.
Bye, y'all.